Linux and Fundamentals Part 2. This episode has 14 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. How do you upgrade or update a Kubernetes cluster? Here's a strong way to approach it. You upgrade the control plane first. In GKE this is largely managed. You trigger or schedule it via cloud or console, then upgrade node pools afterward. Typically one pool at a time using a surge or rolling upgrade strategy, so new nodes with the newer kubelet version are added and old nodes are cordoned, drained, and removed gradually. Always check the Kubernetes version skew policy. Control plane can be at most a few minor versions ahead of kubelets, and review deprecated or removed API versions in the target release before upgrading, since workloads using removed APIs will break. Nice. Let's continue. Question 2. How does the GKE API server control plane expose traffic, and how do clients reach it? Here's a strong way to approach it. In GKE, Google manages the control plane, API server, scheduler, controller manager, on Google-owned infrastructure and exposes the API server through a public or private endpoint, configurable, fronted by a load balancer with TLS. Kubectl and other clients authenticate via IAM-backed credentials or tokens and reach the API server over that endpoint, while node-to-control plane and pod-to-API server traffic within the cluster is routed over the VPC, using connectivity or tunnels for private clusters where nodes have no public IPs. Great. Moving on. Question 3. What is ETP, and what happens to the cluster if ETP goes down? Here's a strong way to approach it. ETP is the distributed, consistent key value store that holds the entire Kubernetes cluster's state. Every object, pods, deployments, secrets, config maps, is persisted there, and the API server reads or writes through it. If ETP goes down, the cluster effectively becomes read-only or fully unavailable for changes. Existing pods keep running. Kubelets continue managing already scheduled workloads, but no new scheduling, updates, or API writes can succeed until ETP recovers, which is why ETP is run as a highly available odd-numbered cluster, typically 3 or 5 members, with regular snapshots for disaster recovery. Alright, next question. Question 4. What does killed mean, and how do you fix it? Here's a strong way to approach it. Killed means a container was terminated by the kernel's OOM, out-of-memory killer because it exceeded its configured memory limit, or the node ran out of memory. Fix it by profiling actual memory usage and raising the container's memory limit to a realistic value, fixing a memory leak in the application if usage grows unbounded over time, or reducing the workload's memory footprint, batch size, cache size. Simply raising the limit without checking for a leak just delays the same crash at a higher memory ceiling. Let's keep going. Question 5. What happens when a Kubernetes node fails and goes not ready? Here's a strong way to approach it. The kubelet on that node stops sending heartbeats to the API server, and after the node monitor grace period, default 40s, the node is marked not ready. After a further pod eviction timeout, default 5 minutes, the control plane considers the node's pods unreachable and, for pods owned by a deployment or replica set, reschedules replacements onto healthy nodes to restore the desired replica count. Pods not managed by a controller, bare pods, are not automatically rescheduled. On to the next one. Question 6. What happens to the horizontal pod autoscaler, HPA, if the metric server goes down during a traffic spike? Here's a strong way to approach it. The HPA controller can no longer fetch current CPU or memory, or custom metrics, so it stops making any new scaling decisions, up or down, and holds at the last known replica count, logging a failed get resource metric or similar event, until the metric server recovers and fresh metrics are available again. This means a traffic spike during a metric server outage gets no auto-scaling response at all, which is why metric server itself needs to be monitored and highly available. Good. Here's another one. Question 7. What are taints and tolerations in Kubernetes? In one line. Here's a strong way to approach it. A taint is applied to a node to repel pods from scheduling there unless they explicitly tolerate it, and a toleration is applied to a pod to allow, not force scheduling onto nodes with a matching taint. Together they let you reserve nodes for specific workloads, e.g. GPU or dedicated node pools. Nice. Let's continue. Question 8. How is a Kubernetes cluster monitored? What tools and approach would you use? Here's a strong way to approach it. The standard stack is Prometheus scraping metrics from Kuba state metrics, object-level state like pod status and deployment replicas, node exporter, host-level CPU or memory or disk, and application or metrics endpoints, with Grafana for dashboards and Alert Manager for routing alerts. On GKE, cloud monitoring or cloud logging provide this out of the box with managed service for Prometheus as an option. Layer in centralized logging, cloud logging or the ELK or EFK stack, and distributed tracing, open telemetry, so you can correlate metrics, logs, and traces when diagnosing an issue rather than relying on any single signal alone. Great. Moving on. Question 9. Kubernetes shows a deployment is healthy and all pods running, but Grafana is alerting that the application isn't working properly. How do you investigate and fix this mismatch? Here's a strong way to approach it. This gap almost always means Kubernetes liveness or readiness checks are too shallow to catch the real problem, so start by checking what those probes actually test. Often just process is up, not app is functionally correct. Then check application level signals Kubernetes doesn't see, error rate and latency in app logs or traces, dependency health, database, downstream API, cache, that the app can't self-report through a basic health check, and whether the alert is a false positive from a misconfigured Grafana query or threshold. Fix at 2 levels. Make the liveness or readiness probes actually reflect real health, or ready endpoint that checks DB connectivity, not just server started, and fix the root cause found in logs or traces. Bad config, downstream outage, resource starvation not yet triggering a pod restart. If the app is silently degraded but not crashing, add or tighten slow-based alerts, latency or error rate, so Kubernetes pass or fail pod status stops being the only signal you trust. Alright, next question. Question 10. What is a Helm chart? Here's a strong way to approach it. A Helm chart is a packaged, templated collection of Kubernetes manifests, deployments, services, config maps, etc. that can be parameterized with values and installed, upgraded, or rolled back as a single versioned release. Let's keep going. Question 11. What is Terraform? Here's a strong way to approach it. Terraform is an infrastructure as code tool used to define and provision cloud and platform resources with declarative configuration. It manages resources through providers, state files, plans, and applies. Detailed interview explanation. Terraform should be explained as part of infrastructure as code. Terraform lets teams define infrastructure declaratively, review changes before applying them, and keep cloud resources aligned with version-controlled configuration. The important production concerns are state management, dependency ordering, module reuse, drift detection, policy enforcement, and secure automation. Production example: in an enterprise Terraform workflow, an engineer raises a pull request for infrastructure changes. CI runs Terraform FMT, validate, security scanning, cost checks, and Terraform plan. Reviewers inspect the plan before apply. Production applies are executed by a controlled pipeline identity, while state is stored in a remote encrypted backend with locking and restricted access. Best practices to mention: use remote encrypted state with locking and backups. Split large infrastructure into modules and separate state boundaries. Pin provider and module versions. Avoid storing secrets in code, outputs, or broadly accessible state. Use policy as code and drift detection before production changes. Common interview follow-ups. Be ready to explain state corruption, partial applies, imports, state migration, workspaces, module design, provider authentication, and how to recover when Terraform state and real infrastructure do not match. On to the next one. Question 12. What is a Terraform state file? Here's a strong way to approach it. The state file is Terraform's record of the real-world resources it currently manages and their attributes, used to compute the diff between desired configuration and actual infrastructure on every plan or apply. Good. Here's another one. Question 13. What is Ansible? Here's a strong way to approach it. Ansible is an agentless, push-based configuration management and automation tool that connects over SSH to apply YAML-defined playbooks, configuring servers or orchestrating multi-step deployments without installing any software on the target hosts. Nice. Let's continue. Question 14. How does Ansible help in DevOps and infrastructure automation, in practical terms? Here's a strong way to approach it. Ansible replaces manual, error-prone server setup with repeatable playbooks. The same playbook configures one server or 1000 identically, eliminates configuration drift by reapplying desired state, and turns operational runbooks, patching, deployments, failover, into version-controlled, peer-reviewed code. In a DevOps pipeline, it's commonly used to provision and configure servers after Terraform creates them, orchestrate zero-downtime rolling deployments, and enforce security baselines consistently across an entire fleet. Great, moving on. That wraps up this episode. Nice work practicing, and see you in the next one.